Welcome back to this live classroom, my dear students and parents who are watching this program. Myself is Rajiv of Charge Indian School. We were in fact just before the break we were talking about a few things about why our students are not coming up to that level with those who are in India in competitive examinations usually. Okay, there are exceptions of course. So, I have been telling about the reasons. First, basically I have observed from my experience, let me tell you. One is about the lack of seriousness in 11th standard. That usually happens because of some reasons, one of the reasons is just after 10th, when they get into 11th, they do not get enough number of days in between, and even if the academic year starts very fast just after 10th, they will not be, students, they will not be that much serious in listening to the classes, and by the time they wake up, they might have covered a lot of contents in the class. So, it will be out of grip. So, that there the difficulties arise for those who are taking up like that, some what is I am talking about an average students thinking level. Okay, so first, so because of that, when even if they are taking up in the after 2-3 months, so they will be struggling to cover up the portions. Second aspect is they may be getting a feedback that okay, 11th standard is internal examinations, so you don't need to worry that much. Even some parents also have the thinking that or 12th you maximum you do, 11th you little bit you relax and enjoy. So, it is a very wrong thinking. So, you should be very much focused on 11th, because this is the basis of whatever you are doing in 11th is definitely the basis, a basic thing which will build your grip in the competitive examinations. All right. Another aspect is some even I have been telling about some students have the thinking of that sort. Some parents also even to an extent think in that way. Even some schools, let me tell you, very wrong. I don't know how what's the reason behind it. They do not complete the portions with that much effort. In the sense, some areas they may skip of 11th standard. A few cases I have noticed, but it's a very wrong approach. You have to complete the entire contents. That will definitely spoil the children. It is not a healthy approach. Have to have the 100% portions to be covered in 11th standard. So, certain areas if you skip, definitely it will affect the preparations for competitive examination, preparations of students. Okay, that is the lack of seriousness due to quick jumping over to 11th from 10th. Then about the thinking that okay, internal examinations or 12th standard we will focus now, we will see. So, these all ways things are getting deviated, or the students they do not be that much in tune with the studies. So, later on in the last phase, even if they are serious, they will not be able to manage to cover up the whole thing as such. So, the ultimate aspect is that when the whole load comes for the entrance exams and all, it would become a difficult thing for them. All right. So, my appeal to the 11th standard students is very beginning onwards, you focus on what you are doing in the class, and once you are tuned with the track of 11th standard, surely you will be able to improve well. So, I hope you could get it clearly. So, my appeal to parents is to monitor in such a way that from the beginning of 11th standard, they are doing their contents in time along with the classes, right. So, that is about 11th standard. Now, from 11th standard, even if now this is the class for 12th. So, those who are watching this program of grade program, the grade 12 students, just see this aspect, what all you must learn thoroughly for doing good in 12th from 11th standard, right. So, from 11th I mentioned before the break, I told you about this one. you have to have a clear picture on the different shapes of graphs, all the aspects related to vectors, vector addition, resolution, what is a dot product, cross product, or everything, whatever you have done in 11th standard related to the vectors, you must revise thoroughly. Why I am mentioning now is because even if in 11th standard you haven't done much or you didn't focus much on those areas, surely you should take up those things, prepare well. Then if you start with 12th standard, it would be easy for you, right? Graph, the 11th standard portions, that is vectors. Then of course, the areas like rotational motion lesson, center of mass from which you have angular momentum, rotational motion, things like that. There are many, the contents of that sort from chapter rotational motion, work energy power. Then from the chapter waves, superposition principle and things like that. Then simple harmonic motion from grade 11, second last chapter, oscillations. Right, that means in fact almost many contents, and in laws of motion there are certain areas like momentum, concurrent forces. All right, so then in work energy power we have the work energy theorem. From the gravitation we have the concepts related to gravity like gravitational force, gravitational potential. All these are useful to compare with what you are doing in 12th and to straight away use those concepts you have done in 11th. So, graph, then 11th standard contents, these many points I have mentioned. Then you should have a picture clearly about use of logarithms. For all the calculations, you are not supposed to use a calculator in the examination, so you should learn logarithm thoroughly. That is another area which may lead to losing marks in the examination if you are not clear with. Right. So, use of logarithms. Then the basic mathematical concepts, especially those who are not taking mathematics as a subject, you focus on the calculus like differentiation, integration and certain identities from trigonometry, algebra. All these, if you refer to the preliminary mathematics page in one of the reference books which are useful for 11th grade, so you will definitely get it. And not only that, in NCERT textbook of grade 11, if you refer the last appendix of that textbook, you will see the mathematical tools or mathematical concepts that are required for you to do physics. Okay, so that's again a useful thing. Okay, the mathematical tools. So that is when we go for like we say, when you go for a journey, we will definitely be equipped with the things which you require on the way. This is what you have to do when you start with your 12th standard. You be ready with the with what all weapons you have to have in the with you to do good on the way. All right. So that's what I said. Once again, let me repeat it. The different shapes of graphs, then the use of calculus concepts, then vectors and concepts from 11th, right, whichever concepts I mentioned, you can definitely revise that. Then use of logarithms, right. And one more factor you should have a clear picture is about conversion of one unit into another. Always the system which we follow, that is SI unit, right, and whichever unit given in the question, that should be converted to SI unit. So, it would be again important to know the conversion factors. Say for example, milli means what? Milli is 10 to the power minus 3, micro mu 10 to the power minus 6, nano 10 to the power minus 9, pico 10 to the power minus 12. So, those conversion factors you should learn. So, you can replace those prefixes with the conversion factor, means multiplication factor. Okay. Then about 12th, one more thing let me tell you is in 12th standard physics, this time there is a very minute change there in the syllabus. So, make a note on that as well. In fact, in electrostatics lesson there is a change in a Van de Graaff generator, you must be knowing now by now, that was there last year. This year it is not seen in the syllabus, and of course towards the end also there are a few changes. In chapter optics there are a few changes, the chapter communication there is a change, and chapter electronic devices also there is a small change. So, these changes you should have an idea about. So, it is better always you in 12th standard especially CBSE is setting up a syllabus for you to prepare. You go through the syllabus at the end of every unit doing in the school, you check what all contents are supposed to be prepared from your side and make sure you have done everything. Okay, so, all the contents are given clearly there. All right. Now, just because it is the first day of this season, I was telling you in general a few things or lot more rather about this, and if any clarifications required also you can get back to me. Okay, so now we will get into 12th physics. All right, so you are ready, right? So, what is the first unit's name? You know, the first unit is actually titled as electrostatics, static electricity. So, today anyway we are not going to discuss the details of everything, but in case if you need any derivations to be done, I am not going to explain as many derivations as possible also. It is not like the normal class. We will focus on the extra questions or numerical problems and clarifying your doubts. We will focus on that. I think it is better, isn't it? If you have something to be done straight, like maybe this particular derivation I do not know, or this question I do not know. So, if you have any specific thing to discuss, maybe one derivation is you find it as a lengthy derivation, you want to shorten it, or should it be done like that, or is that much required for the exam. If you have anything of that sort to ask, surely you can get back to me. So, because over here like myself and other teachers, they will have from their experience, especially the teachers who coming over here, they have so many years experience. So, from their experience, why experience is an important factor is because they will come to know what all possible mistakes students make. So, from the by evaluating the papers of students year after year, they will come to know it is a routine mistake, everybody is, or most of them are making mistakes of this sort. So, we will be able to tell you what mistakes you may come across, right. In that way you can avoid that, in the examinations you will not make mistakes there. All right. So, today I will brief you a few things of the first chapter, basic equations and concepts, and we will do some questions as well. Okay. So, before that I think we will solve one question. I will show you one question. Okay. Can you Mrs. Tangel, can you show this question? Okay. See, you can see this question. First question you see, two insulated charged copper spheres A and B of identical size of charges Q A and Q B respectively. A third sphere C of the same size but uncharged is brought in contact with the first and then in contact with the second and finally removed from the both. What are the new charges on A and B? This is one question. So, all these questions are basically collected from sample papers. So, we will see now one by one. Okay. So, first actually to begin with I thought of discussing one question, then I will tell you a few things more. Okay. Now, listen to the board. There are two charged spheres A and B. Okay. It has charge A, QA, and this has charge QB. So, these two they have identical sizes. Okay. They have charges QA and QB. Now, what happens is a third sphere C, okay, identical size. It is kept in contact with first A, right. Then it is kept in contact with B. So, first A, then B, then removed from both. The question is, what will be the new charge on A and B? All right. So, how to make it? When C is kept in, C has no charge, okay, it is uncharged. When C is kept in contact with A, because being identical size, what happens is the charges will be equally shared, right. So, charge of A would become what? Half will be given to C. So, A's charge will become QA by 2, correct. And how about C's charge? That also will become QA by 2, equally it will be shared. So, with that charge it will touch the sphere B. Okay, when it goes to B, what will be the charge on B? It was having a charge QB already. Along with what also is coming? The charge of A, a charge of C. C is how much is the charge of C? QA by 2. QA by 2 is coming and it is touching B. So, what happens is this charge, this is QA by 2 now. So, QA by 2 and this is originally having a charge QB. So, QA by 2 and QB. Okay, so, they have charges when they are kept in contact, what happens is again their charges are equally shared. Equally shared, how it is possible? We can say QA by 2, this is charge on C, plus QB charge on B, the whole divided by 2, half. Okay. So, that is the new charge of, then C is taken away. So, this is going to be the new charge of B. So, A's charge will become QA by 2, B's charge will become QA by 2 plus QB the whole by 2. Is it clear? So, the basic concept is charges are conserved. You know, you studied in the first lesson conservation of charge. Charges are conserved, total charge is not changing. So, whatever charge present over there will be, if they are of identical size, they will be equally shared. That is the case, clear? But you know, there is one similar question we have, it is there in the textbook as well. Might have seen this question. It's basically related to what is done in the second chapter. Okay. See, one question. Can you see the second question? See, go through the second question. Calculate the amount of work done in rotating a dipole. 3 into 10 raised to minus 8 coulometer from its position of stable equilibrium to position of unstable equilibrium in a uniform electric field of intensity 10 raised to 4 Newton per coulomb. So, what all things given over here is, see, when you read a question, very first you see, all of you, I hope all of you can see the question. Okay. Calculate the amount of work done. So, first what is the question? W is the question, right, in rotating a dipole of dipole moment, which letter we use? P is equal to 3 times 10 to the power minus 8 coulometer. Okay, from its position of stable equilibrium to position of unstable equilibrium in a uniform electric field of 10 raised to 4 Newton per coulomb. Now, can you say what is the meaning of stable equilibrium and unstable equilibrium? What is the meaning? Can you make out what exactly is the difference between stable equilibrium and unstable equilibrium? See, if I will tell you an idea about getting an idea about what is stable equilibrium and unstable equilibrium. Just imagine you are sitting on the top of a building or top of a tree. So, when you are sitting on the top of a tree, of course, you have to hold the tree properly, otherwise you will fall down, right. So, suppose when you are falling down to the ground, will you have the tendency to go up again to the same point? No. That is because it is unstable. That condition is unstable equilibrium. Got it? And a person on the ground, we may say, normally we say he is stable, right? He may be in stable equilibrium, but there again one thing to understand is the stability depends on something else. Say for example, there is a big well near the person, there is a big well, okay, a deep well. So, on the ground, from the ground he may fall into the well as well now. So, even if he is on the ground, he is not stable, right. When he is inside the well, just say assume person inside a well, just think of 3 positions: person inside well, person on the ground and person sitting on the top of the tree. Who is most stable? You should know stability means what? If you are stable, when the position is disturbed, you will have the tendency to come back to the same point. Then only we can say you are stable. Okay, if somebody is falling, but he will come back to the same point, means again, say if there is a bowl, on the bowl, if you are keeping a spherical ball, if you displace it, what happens? It will come back to the same point. So, it is stable. But if the bowl was kept like this and the ball is kept on the top of that, then what will be the picture? If you displace it, it will not go back. So, it is unstable. This is stable. This is what the picture, I was asking about this one. A person at the inside a well, person on the ground, person on the tree. Who is the most stable position? Who is in the most stable position? The person inside the well. Because he is inside the well, he will further not fall anywhere now. On the ground, person can get into the well, right. On the top of the tree, of course, it is very much unstable. This is the picture to think of. So, in terms of potential energy, what you can say, negative potential energy is inside the well you can say negative potential energy. Ground reference level 0, up positive, positive 0 negative. So, negative potential energy is the most stable position, positive potential energy is the most unstable position. So, in this question you have to calculate the work done to rotate a dipole from stable equilibrium to unstable equilibrium, stable equilibrium to unstable equilibrium. So, you know the equation for potential energy we have is minus Pe cos theta. So, when theta is 0, potential energy is minus Pe, negative potential energy, that is most stable. If theta is 180 degree, cos 180 is how much? Negative 1. Negative 1 into negative Pe is what? Positive Pe. So, when theta is 0, the potential energy is how much? Minus Pe. When theta is 180 degree, the potential energy is plus Pe. So, this is unstable position, this is stable position. See, stable, unstable. So, when a dipole is rotated from stable equilibrium to unstable equilibrium, how much work is done? You know, what is the equation for calculating work done? W is equal to Pe into cos theta 1 minus cos theta 2, right, cos theta 1 minus cos theta 2, that is Pe times theta 1 is how much? 0, stable equilibrium 0. So, cos 0 minus cos 180, cos 0 is 1 minus minus 1. So, it would be what? 1 plus 1, right, 2. So, the answer is 2 Pe. So, P and E values are given now. So, 2 times P times E, that many joules. Okay. So, that is the value of the total work done. So, is it clear? It is an important question. Work done to rotate a dipole from stable equilibrium to unstable equilibrium, from theta is equal to 0 to theta is equal to 180 degree. So, just try to make it out, that is the way the calculation is. Okay. Now, today we could discuss only 2 questions basically, because of course, it was an introductory session, and next day we will take up more questions based on these contents. And my request to you is that please listen to this program and note down the questions you want me to explain. This is something which is important, and tell us, okay, this particular question I have to explain, or if you refer the textbook and say this page, this question number, this particular question how to do, that all we can make it. Anyway, let us see, hope you will attend the remaining classes as well. So, preceding days also, every day you have from 5 to 6. So, watch the remaining programs as well, remaining live classroom as well, all the coming days. So, let us go ahead with a smiling note, and for today we are winding up, and tomorrow with another subject, again this program will be there, and stay tuned with NTV. Let us see again next week.